All right, 9-5 practice. So similar idea to graphing lines, except remember we're shading an area. Also remember, whenever you have greater than or less than, we're going to use dotted lines. And when you have less than, greater than or equal, we're going to use solid lines. One of the most common mistakes. And remember, if you ever accidentally draw a line when it should have been dashed, a dashed line, you could also just go back and erase. You don't have to erase everything. You can just kind of make your own dotted line. Don't worry about it. Doesn't have to be perfect, just so you show the idea that it's dotted. So x is less than 8. Well, remember, x equals 8 is a vertical line at 8. So I am going to draw a vertical line, dotted line at 8, like so. And then you really don't have to test here because it's kind of obvious. Less than is to the left, greater than is to the right. But as I said in the previous unit, don't go ahead and go crazy with shading. All you have to do is just draw some simple lines like this, especially in this unit. We're going to be doing so much shading and overlap, you will bury the answer if you shade everything in color. And I know some people still go ahead and shade everything. You're going to be creating a nightmare for yourself if you do that. Just simple lines. Okay? And again, colored pencils work really well here using different shades. Now, on the next one, we really have 3x plus 0. Okay? So 0 is our starting point, and that's our y-intercept. And we're going to go up 3, 1, 2, 3, right 1, and 1, 2, 3, right 1, 1, 2, 3, right 1. And technically all these are actually open dots. You're not going to lose points for this. But technically they are. Then down 1, 2, 3, left, 1, 2, 3, left, and so forth. And the more dots you put, just the easier it is to draw that line. Okay? And then I'm going to connect that like so. Now, on this one, yes, you do need to do some math and figure out which way you're going to shade. Okay? So you test a point. You can't test 0, 0 because it goes through 0, 0. So just pick something obvious, like out here maybe, 10, 0. Okay? If I plug in 10, 0, I'm going to have 0 is greater than 3 times 10. Okay, I plugged in 10 for x and 0 for y. Well, 0 is not greater than 30. That's a lie. Which means I am shading everything to the right of this, like so. And again, simple lines, okay? And now the answer is, where is the overlap? And here's where you can shade. And the overlap, you can kind of just draw like a solid shape like this, and then kind of go to town. And you don't have to shade the whole thing. Just the idea that, oh, there's the answer. And that's all we're looking for. Okay? Next one. So I'm going to use the cover-up method here. Very easy. Y is 1. And x is 1. Okay? And so that is, you can tell, going to be a -1 slope, like so. And you really just have a diagonal line. And it is a solid line, again, because of the fact that it is less than or equal to. Okay, so there's my line. Obviously, arrows. Okay, and I got to pick a point. And again here, I can use 0, 0, and that's the easiest one to use. So if I plug in 0 for x and y, I get 0 is less than or equal to 1. That's true. That means this point is in the true zone, so I am shading this way. That's all I need. That's all the shading I need. Okay, and I can do the cover-up method again here. Be careful. Okay. So here I would have to divide by -1. So y would be -2. Okay, and then plug in the 0 there. X would be positive 2. All right. And there's my line. Try to get this to be a little bit better. I mean, it's not as big of a deal when we're dealing with regions like this right here. Not as huge, but still want to be as accurate as possible. Okay, and now, again, I'm going to plug in 0, 0. So 0, 0 would be 0 is greater than or equal to 2. Well, that's false, which means this point right here is a lie, so I'm going to shade this side. Now, where's my overlap? Right in there. Okay, that's enough. You get the idea. All right, again here, I'm going to use cover-up method. So y would be 2. 6 divided by 3 is 2. That's not what I wanted. X would be 6. I'm going to be doing a solid line. Like so. Okay, there's that line. And I'm going to test. I'm going to plug in 0, 0. 0 is less than or equal to 6. That is true. That means this point is true. 0 is less than 6. So I'm just shading this way. Good enough. Now I cannot do the cover-up method here because 2 and 4 do not go into 7. So I'm going to have to do a little rewriting. So I'm going to move the x over. You get 4y is greater than or equal to 2x plus 7 and divide by 4. Y is greater than 2/4, which is 1/2 x, plus 7/4. Okay, which is 1 3/4. So this is going to be not exactly accurate, obviously. So we're going to go to 1 3/4 and put our dot. It's going to be right underneath this one. Okay, and then we're going to go up 1, right 2. It's going to be right underneath that line. Underneath that line. And that's going to be good enough to give me tracking data. That ended up pretty good. Not too bad. Okay. And then I'm going to plug in 0, 0 here. I'm going to go back to the original though, because 0 greater than or equal to 7. That is a lie. Okay. Which means I'm going to shade not on this side because 0 was wrong. I'm going to shade this way. All right. Which means where's my area? It's right there. Well, that's good enough. Now, where are we going in this chapter? We're going this way. We're going to end up having 3 lines often. So, first one. First off, I'd like to pay attention that I'm going to have 2 dotted lines and 1 solid line. Sometimes it's good to make a note of that beforehand so you don't lose it as you get going. So the first one. 7 is my y-intercept, and my slope is -1. So that's a simple, whoops, that was a little slanted there. All right, and that one, I can actually freehand that one because I have all those wonderful dots to do. And I still wasn't perfect, but you get the gist. And I'm going to test 0, 0. So if I plug in 0 for y, less than or equal to 0 plus 7 is 7. 0 is less than 7. That is true. Okay. So there we go. That's good enough right there. If I want to do one more, cool. All right. This one I'm going to try to use the cover-up method. So remember, be careful. That's a negative one I have to divide by. So that's going to make it +4. So y is +4. Cover-up method. X is -4. All right. So there's my line. I'll fix that up a little bit. Not too bad. Okay. Now, I'm going to pick 0, 0 again. 0 is less than -4. That's not true. 0 is not less than -4. 0 is greater than every negative number. So this point here is false, which means I'm going to go this way. So you can kind of see, I'm going to erase this, but you can kind of see right now where the overlap is. It's going to be in this area. Okay, so far. But I'm going to erase that because we have one more line to do. And I'm going to do the cover-up method again because this one's really easy. Y is 0. Actually, I won't use the cover-up method. I lied because I'll get 0 for both points, and I cannot connect 0 and 0. So I need to move this over here, which means I'm going to get y is greater than -4x plus 0. So again, that does mean I'm going to have my starting point at 0, like I said before. But my slope is -4. So down 4, left 1, down 4, left 1, up 4, right 1. Nope. I just drew a positive slope, didn't I? Down 4, right, down 4, right, up 4, left, up 4, left. That turned out pretty well. Yeah, it's pretty good. So there's that. And now I can't test 0, 0. Okay, so I'm just going to test this point again that I did before, 10, 0. Okay, so if I do that, that's going to give me 10 times 4 is 40, plus 0 is greater than 0. 10, 0 is true. So that's going to give me, watch this, everything here. Well, if you remember where I kind of hinted at before, it's under this line, right of this line, above this line. That's my area right there, that little triangular spot right there. Okay? And you can tell, even with drawing these simple lines, how it's like, wow, that's getting a little confusing. If you shade everything, it just makes it almost impossible to do these problems. All right, last one. This is a big one. Okay, so I'm going to use the cover method here again. So that's going to give me y of 4. Okay, divided by 3, y is 4. Boom. Move this. It's -2, so I divide by -2, and we don't have to worry about flipping symbols here because we're just getting a dot. When I divide by -2, x is -6. Okay. Also, just pay attention. Solid line, dotted line, dotted line. These two are really important. Going to come into play a lot here. They basically mean that we're only going to be dealing with the first quadrant. Because x has to be greater than 0 and y has to be greater than 0. All right, back to this one. Okay, there's that. I'm going to plug in 0, 0, which I'm going to end up with 0 is less than or equal to 12. That is a true statement, which means 0, 0 is true, so everything down here is true. All right. I can use the cover-up method again here. So divide by 3, y is going to be -2. Again, this should be technically an open dot. We don't get picky about that, but okay. And because nothing on that line will actually count, and x is going to be -3. All right. And then I'm going to use this one. Try to do my best. Oh, that's not bad. Until it keeps moving. Not bad there. Okay, so on this one, I'm going to plug in 0, 0. 0 is greater than -6. That is true, because 0 is greater than every negative number. So that means I'm going this way. Now, kind of like I did before, you can see where's the green and the blue. Right now, my area is going to be about there. But we have a third line to do. This one has a y-intercept of 4, so going through this point again, right here, and a slope of -3. So down 3, right 1, down 3, right 1, down 3, right 1, up 3, left 1, up 3, left 1. So I'm going to get a dotted line again. That was pretty darn close. I can test 0, 0 again. So 0 less than, 0 makes the -3 go away, 4. Is 0 less than 4? Yes, it is. So I'm going to shade left of this dotted line. So where's my overlap area? It's left of this line, it's upright of this line, and is below this line. So is this triangular area right there.